All right, today we have a short lesson on using the Pythagorean identities that we talked about Monday, Tuesday, and putting them in different formats so that we can use them to simplify expressions or prove identities. So what do I mean by that? Well, right now we have cosine squared plus sine squared minus or equals 1. What if I wanted to just solve for cosine squared? I could say cosine squared theta equals 1 minus sine squared theta by just subtracting sine squared theta from both sides. I also could say that sine squared theta equals 1 minus cosine squared theta. That's just a couple ways I could manipulate this Pythagorean identity to get something else. We can do the same down here. I could say that tangent squared theta equals secant squared theta minus 1. Or I could say that secant squared theta minus tangent squared theta equals 1. It's just a couple different ways to rewrite that. And the same down here, I could solve for cotangent. So cotangent squared theta equals cosecant squared theta minus 1 by subtracting 1 from both sides. Or if I subtracted cotangent from both sides, I get cosecant squared theta minus cotangent squared theta equals positive 1. So those are 3 ways. I'm just going to scroll it up the screen so that you guys can make sure you have them in your notes. Now we're going to look at a few problems on the next piece of paper at how we're going to use these Pythagorean identities, so have them nearby, to simplify these expressions. So 1 minus cosecant squared. So what you want to do is you want to find an identity or a Pythagorean identity that has cosecant in it. So we can see right here that we have cotangent squared plus 1 equals cosecant squared. Now we want to get it into some form that looks like that. So if I took my first identity and I had cotangent squared theta plus 1 equals cosecant squared theta. Now I want to get it 1 minus cosecant squared theta. So I subtract this from both sides. So right now what I have is cotangent squared theta plus 1 minus cosecant squared theta equals 0. But I just want to know what this equals, so I'm going to subtract the cotangent squared theta from both sides. Oops, that should be an exponent, not a 2. And so I now know that to simplify this expression over here, that 1 minus cosecant squared equals a negative cotangent squared theta. Right. This next one, sine squared plus cosine squared theta. I want to find a Pythagorean identity that involves sine and cosine. So I bring in my Pythagorean identity. I see that the only thing they did was they just swapped sine and cosine. So this one equals 1. Now we have one involving tangent and secant squared. So if I want to simplify this one, I need to find a Pythagorean identity that uses tangent and secant squared. So we just did that one there. And right now we had secant minus tangent equals 1, but this is the other way around. So if I start from the beginning using 1 plus tangent squared theta equals secant squared theta, I want to have tangent by itself, so maybe I subtract 1 this time first. I get tangent squared theta is secant squared theta minus 1. And now to get what they want up there, I'm going to subtract secant squared theta from both sides. And so I can see that tangent squared theta minus secant squared theta equals -1. And then last but not least, this is really similar to this one up here. Notice sine squared plus cosine squared equals 1. Well, now it's negative sine squared minus cosine squared. So to me, it looks like they took my original Pythagorean identity and just multiplied it all by -1. So maybe they went like this. And that would give you negative sine squared minus cosine squared. But now we want to distribute that -1 to 1, and so this must equal -1. So today you're going to use the 3 Pythagorean identities that we started with on Monday, Tuesday, and you're going to be moving them around to answer questions similar to these.